Be like a proton, be positive, and stay away from the electrons because they attract. With this positive thought, I, Arpita Tripathi, welcome you all to my channel and your very own learning platform, The World of Chemistry. Today, I'll continue my discussion from the last topic, atomic structure. So keep watching my videos, and to know about my latest updates, do the needful. From this module, you'll collect some information about modern concept of atoms, electronic configuration, atomic number and mass number, stability of atom, and valency and variable valency. So let's see what the modern atomic theory says. It tells that the atoms are made up of three fundamental subatomic particles, that is, electrons, protons, and neutrons. There are two structural parts of an atom, that is the nuclear part which contains the nucleus and the extranuclear part which contains the electrons. The nucleus is positively charged, centrally located. It is positive due to the presence of the positively charged particles, protons. An atom is electrically neutral due to the presence of same number of electrons and protons. This is the structure of an atom containing the positively charged protons, neutral neutrons. Protons and neutrons are present inside the nucleus of an atom, which is a small, dense area present at the center of every atom. Protons and neutrons are together known as the nucleons. As they are present inside the nucleus of an atom, so they are also called as the nuclear part of an atom. The nucleus of an atom is always electrically positive due to the presence of the positive protons. Electrons are present outside the nucleus of an atom at their own revolving orbits around the nucleus. As it is present outside the nucleus, so it forms the extranuclear part of an atom. Electrons are the negatively charged particles. Protons, electrons, and neutrons are the fundamental subatomic particles of an atom, as these three particles are present in each and every atom of each and every elements. Due to the presence of these positive protons and negative electrons, the atom is electrically neutral. In this image, X represents the chemical symbol of an element, where symbol is defined as the shorthand representation of the name of an element. A represents the mass number or the atomic mass of this element X. Mass number is defined as the total number of protons and neutrons present. So, it is also known as the nucleon number. Z is the atomic number of the element X. It is defined as the total number of protons present. Hence, it is also known as the proton number. In a neutral atom, the number of protons is always equal to the number of electrons. Now let's know what is an electronic configuration. Electronic word represents electron related and configuration means arrangement or layout. So it is defined as the arrangement of electrons in the well-defined shell. The shell present just next to the nucleus of an atom is named as the K shell, and the remaining shells are L M, N shells. So, in the structure of an atom, the outermost shell is known as the valence shell, and the electrons present in the valence shells are known as the valence electrons. So this is how the respective shells are named. First is K shell, second is L shell, third is M shell, and fourth is N shell. Each orbit can hold a specific maximum number of 2 n square electrons in it, where n is the shell number. First shell K, here the maximum number of electrons accommodate is 2, where n is equal to 1. The second shell L, here in n the number will be 2, so the maximum number of electrons can accommodate here is 8. In the third shell, same formula 2n square, so n is equal to 3. Hence 18 number of electrons can accommodate, and similarly in the n shell 32 electrons can accommodate. Next is chemical stability. An atom is chemically stable when its outermost energy level has the maximum number of electrons. The stability depends on whether its outermost shell is filled with electrons or not. If the valence shell is filled, then only the atom will be stable. For example, here in the helium structure you can see it has only the K shell, and as K shell can accommodate maximum of 2 electrons, so helium is having that, hence it is a stable atom. All other elements are stable when they have 8 electrons. Exceptional is hydrogen. It means the element should have octet configuration, which is the stable state. Octet configuration means having 8 electrons in the valence shell. The noble gases are the elements that are most stable due to the maximum number of valence electrons present in their outermost shell. And the noble gases are as follows: helium, neon, argon, krypton, xenon, and radon. This is why the noble gases are the happy atoms and are unreactive. Here you can see 2 atoms of hydrogen and helium respectively. Hydrogen, because having 1 electron in its outermost shell, it reacts with other elements, while helium doesn't. In this oxygen atom, the electronic configuration is 2, 6. So outermost shell is having 6 electrons. For this, either it will be sharing electron or it will borrow. But borrowing will be easier for it. So to obtain stability, oxygen needs 2 more electrons in its outermost shell. For this, it reacts with hydrogen and shares its outermost electron with hydrogen, where oxygen completes its octet configuration and hydrogen also has 2 electrons in its outermost shell. And this is how the chemical reaction takes place. So, by giving or accepting or sharing of electrons between the atoms leads to the formation of compounds. To obtain stability, the atoms need to have the octet configuration. It means the first shell should have maximum 2 electrons and second or third or fourth shell, whichever will be the outermost, will have maximum 8 electrons, that is the octet state. Now let's know about valency. It is the combining capacity of an atom of an element to form the chemical bond. Or it can also be defined as the number of valence electrons that can be lost or gained or shared to complete its octet. Now, we understood what valency is, but the important question arises is how to find it. Usually, metals have 1, 2 or 3 electrons in their valence shell. They lose these valence electrons during the chemical combination. So, the valency of a metal element is always equal to the number of valence electrons in its atom. For example, the valency of sodium, its electronic configuration is 2, 8, 1. So, it loses its 1 electron to obtain its octet configuration. Hence, the valency of sodium will be 1. Valency of magnesium. In magnesium, the outermost shell has 2 electrons. In order to become stable, it will lose 2 electrons and hence the valency will become 2. But in case of nonmetals, the valence shell contains 5, 6 or 7 electrons. Hence, they accept 3, 2 or 1 electron to complete the octet. So, the valency of a nonmetal element is usually equal to 8 minus the number of valence electrons in its atom. For example, valency of chlorine. In its outermost shell, the valence electrons present is 7. So, to become stable, it needs only 1 electron. Hence, the valency will be 8 minus 7, which is equal to 1. Now let's see the valency of oxygen. Its electronic configuration is 2, 6. So it needs 2 more electrons to become stable. Hence, the valency will become 8 minus 6, which is equal to 2. Exception is there. Hydrogen, being a non-metal, has the valency equal to its valence electrons, which is 1. The elements with valency 1 are the monovalent elements. For example, lithium, hydrogen, potassium, etc. The elements with valency 2 are divalent elements. Example, magnesium, calcium, sulfur, etc. The elements with valency 3 are trivalent elements. Example, aluminium, phosphorus, nitrogen, etc. The elements with valency 4 are tetravalent elements. Example, carbon, silicon, germanium, etc. Now let's know what is variable valency. Sometimes, because of different conditions under which a chemical reaction takes place, the valency of the same element changes. There are some elements which exhibits more than one valency. Such elements are known to have the variable valency. For example, copper, iron, lead, silver, mercury, they all have variable valencies. How the elements with variable valencies are named? Here is a list of elements showing variable valency. If an element exhibits two different positive valencies, then for the lower valency use the suffix OUS at the end of the name of the metal. For higher valency, use the suffix Ic at the end of the name of the metal. Here in the example you can see copper, its lower valency is 1, so accordingly it is named as cuprous. Its higher valency is 2, so it is named as cupric. And it goes on. Argentus, argentic. Mercury, it is mercurous, mercuric, and so on. The transfer or sharing of electrons between atoms leads to the formation of compounds, and the force with which these atoms are held together is called chemical bond. The bond in which one atom of an element transfers its valence electron with another atom of an element is called ionic or electrovalent bond. Some examples of compounds formed by ionic bond are sodium chloride, magnesium oxide, potassium oxide. First question, what is the basic unit of matter? Answer is atom. Name the three fundamental subatomic particles of matter. It is protons, neutrons, and electrons. What is the electrical charge of protons, neutrons, and electrons respectively? Protons are positively charged, neutrons are neutral, electrons are negatively charged. Next question. Lithium 73. What write the atomic number and atomic mass? Atomic number is 3, atomic mass is 7. Potassium 3919. Its atomic number is 19 and atomic mass is 39. Question 6. An atom has 11 protons and 12 neutrons. Find out the number of electrons, atomic number and mass number. Name the element. Third bit is write the notation of the element with its atomic number and atomic mass. Number of protons given is 11 and neutrons is 12. Number of protons is equal to number of electrons is equal to 11. Number of protons is the atomic number, that is 11. Mass number is equal to protons plus neutrons, it's 23. Name of the element is sodium and its notation is Na2311. Next question. An atom has 16 protons, its atomic mass is 32. Find out the number of electrons, atomic number and number of neutrons present. Name the element and write the notation of the element with its atomic number and mass number. Number of protons is 16 and atomic mass is 32. So number of electrons will be 16, atomic number will be 16 and protons will be A minus Z, that is 16. Name of the element is sulfur and its notation is S3216. So, thanks for watching. I hope up to this you have understood well. Have a great day ahead.